Okay, hello, good afternoon, everybody. Once again, I would just like to ask you to turn your cameras on just for a second to say hello to the speaker. But anyway, thank you all for joining the afternoon session. We'll be having this session with Vanya Chok, who is going to be the speaker, and she's also from the Laboratory for Engineering Design, which is the same as the previous two speakers of the day. So Vanya is a senior researcher here at the Faculty of Mechanical Engineering, University of Ljubljana, and her research touches the topics of the perception of 3D shapes, in general, a lot of industrial design, as well as the multicultural issues in product development, virtual teams, all of these kinds of topics. So I'm sure this is going to be a very, very interesting presentation from the side of Vanya. And as always, I'm going to post the link to the evaluation of the trainings after day one in chat, so you'll be able to give us some feedback and let us start with the session. So Vanya, thank you for joining us. Thank you for accepting the invitation, and the floor is yours.
Hello, everyone. Thank you for invitation, and also good afternoon. I will share my screen. I hope you will manage to see it. Can you see my screen?
Yeah, everything seems great. Thank you.
Okay, thank you. So I will introduce you a little bit about, I will present you a topic of industrial design and development. But before we arrive to industrial design, I would just like to show you what we actually do in our study curriculum. So I will present you three courses. One of them is engineering design methodology, basically product development. The another course is computer-aided modeling of geometry. This is the modeling on the level of solid and surface modeling. And then we will jump to industrial design. What is the role of industrial designers? How to create portfolio and make yourself visible on different platforms, and what are actually the remote opportunities. So these three subjects that I will present you, I'm also involved in. So I do the practical part of those subjects. So the first one is engineering design. All the subjects are the first level Bologna degree. So the engineering design methodology is consisted of 30 hours of lectures and 30 hours of practical work. So the students learn about whole product development procedure from idea to the prototype. This happens in year 2 and year 3. Then in the first year, the students already start with computer-aided modeling of geometry as well. 30 hours of lectures, 30 hours of practical work. And we also had an old program, because right now we are shifting from the old programs to the newer ones. So the old one was happening in the third year, and it was named Product Design and Development, as well, consisted by 30 hours of lectures and 30 hours of practical work. Why is this important? Because this is the basis actually of understanding what is the procedure of product development, and also very important part in this is also CAD modeling. So both skills or both understanding could be crucial when you present yourself publicly and you are actually trying to gain or get some online or remote jobs. So now I will just show you what are engineering design methodology objectives to create a deeper understanding about what we teach our students. So objectives are the importance of the product. So we have variety of products. So the students really need to understand what is meant to be designed or developed. The another thing is that they need to gain this understanding of how to systematically develop something. And another thing is how to actually involve different stakeholders in this process. So also they learn a little bit about ergonomics and engineering, how to involve this or how to implement this knowledge into engineering design process. They also have to understand the user needs and engineering specifications, so how to convert user needs to engineering specifications. And they learn just basic creative design methods and techniques when they need to develop something, like working principle for fulfilling a special function of the system and so on. They also learn the guidelines for embodiment design and concepts, and they also learn about prototyping in engineering design process. So this is for engineering design methodology. Now we will go to product design and development. This is the old program, which will not be relevant anymore after next year. But still, we have teach the students here how to find the opportunities for new product development. So it was basically the emphasis on data-driven design, so how to gain as much information to receive the green light to start product development. So this is like some sort of pre-development process that they were taught. But also this subject was divided to surface modeling. So they have not only learn about how to gain the information and gain the data about some potential opportunities for new product, they also have learned how to actually materialize the idea with using the CAD software for complex surfacing and so on. So I think that's very important. Maybe the engineering students, they don't find it interested. They maybe are not so interested into data analysis of the market and so on. But this is a very important step if they will be somehow involved in the product development to understand what it means to develop the right product or to address the right problem, and to fulfill really the needs of some market. So with computer aided, sorry, you're not able to see the whole screen, I'm afraid. So with computer aided modeling of geometry, we provide the students the knowledge of 3D modeler. So they use the software and they learn different procedures how to actually create a model into the 3D space. They also learn about how to present 3D model, so what kind of informations are required, and also how to convert 3D model to technical drawing, for example, like to two-dimensional space. So in engineering design methodology, I will now go a little bit more into details what we and how we understand the terminology of each thing that I will present you. So the product development we see as the set of activities starting with the perception of the market opportunity and ending with the sale of the product. Engineering design we see more like a technical area where the technical system is developed and it should of course work, while the industrial design is more related to aesthetic, ergonomics, but also as well to the function of the product. While the product design it is tricky because product design, it is understood as just a small activity in the product development process, but it is also understood like developing, like product development of the, I don't know, user experience or apps. So this term is often used for software engineering area. So it could be a little bit confusing. So we are using product design for this stage of imagining, creating the product that is solving some sort of problems of the user. And product planning, it is actually the activity that happens before we even start to develop the product. So we plan which team will be at some product, so what kind of resources we will use, and so on. Okay, so these are all interactions. So it's a process where we have the interaction between the design, the industrial design, and engineering design. So all these things are somehow in some point combined together. It really depends by the type of the product, whether industrial design is needed. So if there will be any interaction with the user, or it will be only a development, for example, of some technical system. So where it is more emphasis on design and engineering design. So more on this technical side. Okay, we also teach the students to implement not only the technological perspective and so on, so to think very broadly, to actually try to search for information when they are starting to understand this engineering design methodology in the initial phases, to actually implement business technology and human values. So what I mean by that is that this is the interdisciplinary process, which could not be like just one flow or just one procedure, right? So it is constantly iterative, it is constantly changing, and also the knowledge of different disciplines and different areas should be considered to actually have some sort of design innovation to achieve this level of newness. In engineering design methodology, we basically implement the methods of like from Europe and from United States. So this product development process that are in the literature that you can find in German books or in at some universities taught in US. So first of all, just example of product development procedure is Paul and Weitz, which is a very old new, but it's basis for all the product development processes developed after that. So what we grasp from this are 4 main stages: planning and clarifying, conceptual design, embodiment design, and detailed design. And also we explain and we elaborate on each step from different perspectives, and we also have the different activities that the students need to understand and use, as well as the usage of different techniques and methods to arrive from the problem definition to the solution. This example is also from VD guidelines. I'm not sure how are you familiar with that, but this is very similar to Paul and Weitz that was presented before. So also we can see 4 main stages, and we can see a similar distribution of the task in those stages. This model is from US, so it's American type of model of product development. which is a little bit more different. It differs because it has it is divided not only by the stages, but also by different areas like marketing, design, and manufacturing. So here you can see that you can track these activities in different stages, which are as well similar to previous models that I have presented. So it starts with the planning and it ends with the production ramp up. We also, in our student curriculum, we implement design thinking process. How we do that? With staying a little bit more time at the first stage, on the stage of empathizing, so that the students really have the opportunity to explore the area of problem. This is very important, so that they have time to explore the user, they have time to explore the market, to understand that industry that they are creating the product for. And then they proceed with defining, so clarifying, they articulate the problem, then they go to concept development, so they ideate using brainstorming a different solution, then they go to prototyping, and they go to testing. But testing, we do this testing like simple simulations for checking the feasibility of the CAD model and so on. So this is basically our model that we are teaching at our practical work and in our lectures. So the students, they receive the open topic. Like this year, they have picked the topic of mobility, and then they have to find the good problem. And then they start to explore this problem, as I mentioned before, defining the user, the market, they do the list of requirements, and they also do the strategic specification list. Then they go to the concept development, where they have to create required functionalities. They are introduced to technical process. They have to understand what is the technical process behind the product, the functional structure, and then they apply the creative methods for solving special function, like with a working principle, because they have a variety of solutions for single functionality. And then they create the combination of this working principle as sketches. So they have 3 different sketches made. Then they do the concept validation. We, of course, provided them different methods, different guidelines in those stages, so that they have the opportunity to really test different techniques in this flow. And also, when they go to embodiment design, they already have one direction. They already have one concept selected, and then they start to build design structure. Then they do the CAD virtual model, and they do the simple cost analysis. At the end, they have to create the improved virtual prototype and the assembly drawing. Now here it's more detailedly explained what is going on in each phase. I will just go briefly through that. So they have to actually have to understand the problem from society, and to convert this problem from society to design problem. So as well, as I have mentioned already before, they need to do the research also about legislation, market, society, users, and so on, about the company. They have to implement all this relevant information in product definition. Then they choose the direction where they will go, in which direction they will go with the next steps, and then they do the requirement list. And this step is very important because when you have the requirement list, when you have written down what you need to fulfill in the product, then you actually can start with the building of the design structure and so on. So here we can see different creative methods that students are introduced. They are introduced to the students. And then here it's the level where they have to make the sketches. They have to validate which sketch has the most potential for further development. And then when they choose one, they go into the details. So they apply the knowledge from ergonomics, material science. They do a very simple numerical simulations. And then they go to create 3D models, drawings. Some of them, which are very enthusiastic about this subject, also do the 3D print of the parts. Or maybe they are so enthusiastic as well that they go and they buy the components and they make physical prototypes for this subject. But it's not, this is just optional. It's not obligatory that they will create the physical prototype. So at the end, we also teach them to create the final presentation. So everything that they have made, the whole procedure that they have taught, they need to present it very shortly. So the basic information about the product that they have created and what they have used it to achieve the final form. With computer-aided modeling of geometry, we teach two different levels. One is, sorry, I'm not sure. Do you see also this layout here? I hope you can, sorry. I hope you're able to see what is here behind. I don't know how to fix that, so I will try to explain what is above here. So in computer-aided modeling, we have the solid modeling. We teach students softwares like SolidWorks and NX. And what we teach them is how to use different design features. We use numerous hands-on examples. For example, this is one CAD model that they have to make. It's a part from vacuum cleaner. It is a plastical part, but they also have to make, for example, the 3D model out of technical drawing, or they have to make the reverse engineering. So they have to measure like a physical part and then create the CAD model out of that. And we also make available to our students to attend the certificate. So SolidWorks company offers certificates. Here you have an example of certificates. So if you enroll in this certificate and you succeed to achieve it, you actually have the number of certificate which is visible to anyone. Anyone can have the access, and there is no time limitation. So once you complete the certificate, the future employee can just check if somebody has really achieved, I don't know, if it's really keen of using the CAD software and so on. So this data about the certificate achieved are public. So I think that's very, very good advantage for the students who learn very well to do the CAD modeling, that they proceed with certificate. We also have published the book on space modeling with SolidWorks, where are all the examples that we teach also our students at our lectures. So we in our creation when we have shaped the program, the lectures, we have thought about what actually is in the certificate, what kind of knowledge is necessary. So then we have reshaped the lectures based on that information. So I highly recommend, if you teach any of institution that is listening this, if you teach 3D modeling, SolidWorks is really offering, and also other softwares are offering certificates, and this is a very good opportunity to actually have to make this available to students, to actually make this possibility open for them to enroll. We also teach the students the surface modeling. This is a little bit more complex. So it's a parametric free-form CAD modeling. You can see the examples here on the right side. And also for this, you can receive the certificate. We also organized the certificates for the students. So basically this looks like it, that we organized the day of the certificate, and then we reserve the computer room, and the students which are interested into conducting the certificate, they can apply to that. Of course, we advise our students that they really are good in CAD modeling, so that they really learn about how to CAD model. So if they had like issues at the lectures, so that they, I don't know, don't complete the CAD model or something like that, we advise them to actually attend the certificate in the current year. So they need to somehow make exercises also outside the lectures. Outside these regular lectures. So this is the book with the cases for surface modeling, also published from the colleagues in our laboratory. Okay, so we have arrived to industrial design. The first thing, industrial design is actually the discipline that is I would say highly subjective. So one design can be a good design for one public, but a bad design to another public. So it's very hard to estimate the beauty or the attractiveness of the product. So here it's the thought from Oscar Wilde. So no object is so beautiful that under certain condition it will not look ugly. The difference between design engineering and industrial design is mainly that design engineering is more focused at detailed design, more on the prototyping, and also the emphasis is at functionality, and also applying different engineering practice. So industrial design, it is more customer oriented. So there should be some sort of interaction between the product and the user. And it is there is a highlight on aesthetic with a function. And sometimes the industrial designers, they do different kind of prototypes in comparison to design engineering. I will show you design engineers. I will show you the example in the future slides. So sometimes they just stay at the level of computer-aided design. And when they have this model, they send the model to mechanical engineer or to engineering designer, so that the engineering designer can complete and can actually adapt this model or product for manufacturing process. Okay, industrial design process, as I said before, it differs also in the procedure. So it's more simplified, and also what happens in all these activities, it's a little bit different than what happens when we have the regular mechanical or design engineering methodology, but basically the sequence of the steps is similar. So the first is the problem definition and design brief. This is the input for designers. And then the designer makes a research. Then it goes to the concept development and the improvement of the concept. And then very shortly, it goes to the prototyping. So prototyping, it's not like the product will be like a functional one, but sometimes it is prototyping only to check how the shape or the form of the product feels, what are the dimensions, what is the appearance, and so on. You can see here the example of the prototype of a shampoo box made from a foam, or you can see the example down here for this embodiment design of the car made of clay. So this is clay modeling, and it also serves just to check what is the shape. Sometimes also it is necessary in the automotive industry, because then they do the reverse engineering. They, for example, at the clay model, they apply different points for 3D scanning, and then they go to the surface completion and so on. So sometimes it helps them actually to create the clay model and can go back to create the final form. Technical value and aesthetic value, of course. Here we have the technical value, which is more important when we create the technical product like machine elements and so on. We can see that here at this point, aesthetic value, it is somehow neglected, this is of course logical. So for some sort of product, the aesthetic value is somehow not really needed. So, but here we can see that aesthetic value increase by the consumer goods, so by the special type of product like jewelry, which is very, very much communicated with the customer by aesthetic value, by different aesthetic, by different kind of styles of special, I don't know, jewelry, necklace or something like that is created. Okay. When we are talking about industrial design, we could not neglect the fact that also here is a special, so how we actually divide engineering design from industrial design is also by that industrial design is actually creating the meaning of the product. So adding the value to the customer by this meaning creation. So meaning creation, basically, it happens at the level of the form. So we have at one side the designer, and on another side we have the user. And in between, it is the artifact, it is the product, it is the form of this product, and it is the meaning that needs to be communicated to the user. So it is some sort of semantic that needs to be considered in this process when developing industrial design products. The another thing which also is important in industrial design is how the designer is addressing the customer needs. So customer needs, for example, when we are talking about these basic needs, and expected needs and unconscious needs. When we see, for example, iPhone here or any other phone, we all expect that this phone will completely function. So we don't have any doubt that if we buy some phone, it will function without any constraints or somehow. But what we also expect, and this is not communicated loudly, is that all these applications will be easy to access and will be easy to use and so on. So this is actually already going into direction of user experience, which is another key segment, another key component, maybe better to say, in industrial design. So to find out what the customer needs, how to communicate this value, and how to actually create the design that it will stand out from competitors and that it will communicate the right meaning to the customer. But of course, just design itself is not enough. So we are talking about the added value at the level when the functionality is solved, when the product works perfectly, and when you have, for example, 3 or 5 different brands and you have to select one product. So for example, you are buying vacuum cleaners and you have the similar price range and you have similar I don't know, characteristics of the product, and then you buy at the level of design. So the design that matches your values, that matches your style or your preferences, at that level, the design really has the added value. Also, what I'm talking about before, I was mentioning that industrial design also needs to be functional. But sometimes the functionality in industrial design is different than functionality in engineering design. So here we have, for example, this box for pizza box, which the first functionality of this is to actually contain or to maintain the product that will be hot at the point when it will reach the customer. But this is also some sort of added feature here, that this box can be a table, for example. So this is some sort of additional functionality that maybe could be appreciated by the customer. So here you can see that you don't need any, I don't know, mechanical system or anything, but you can make the most from only creating different compositional or product architecture from one piece of material. Another thing, so the role of industrial designers. So as I have mentioned now many times, so its appearance of the product is not enough. So it's also the role of industrial designer to combine these functionalities and to have also in mind what kind of manufacturing process will be the best for for the product that he is designing. And also, of course, the experience that he will offer to the customers. So here it is an interesting example how we have the match of engineering design and industrial design. It is the case of Italian company Dallara. Maybe you have already heard about it. So they are the engineering consultancy company. They are making racing cars for Formula One. And what they are offering are different simulations and so on. But at one point, they have realized that they will maybe make even more money, or they will gain bigger revenue if they will create their own car. So for now, they were just like offering a service, like simulations and so on. So at the end, what they have done, they have created their own design of the Roadster, combining with the knowledge that they have from engineering consultancy, which is knowledge that they have how to do the embodiment design, which components put where, and so on. So this is a very good example how to actually create added value in this context. At the beginning of the industrial design process, we need to have a very good design brief. Design brief, it's a document where it is written how you understand the background of the project. And often it is communicated with the customer that offers a design. So for example, first you need to understand who is the client, what is the brand image of the client, how the brand image want to be communicated in the public, and then you go to the communication needs, the purpose of the product, and so on. So here it is very structurally communicated what needs to be developed or what needs to be designed. And here, what I mean by that, it's like if they want to design a design of a new sport shoe, here it needs to be very specifically set. Okay, we would like to have the new line of design shoes, but with retro look, or maybe with some sort of, I don't know, adaptations for this and this market. So this is the document that also needs to specify the audience. So who are the users? Which user group? Are these older people, younger people? What is their social economic status, and so on? What is the context? So what are the constraints? Maybe also the constraints with the budget, what can also affect the choice of materials, and so on. And what is the expected presentation? So a designer, when he will be hired, or she, he will receive, if this will be like a serious company that has already experience with hiring the designers, he will receive the design brief. And based on the design brief, he or she will start to create a product. So this is the input for a designer. And this is also the input that you can find on different platforms where companies are hiring the designers, or where companies are looking for some skills or some additional help. I mean, sometimes it's just a brief explanation of the product, but the professionals, by my experience, they have a design brief very, very, very well described before the project is started. Important step to be visible, important step to somehow show what you have learned in the process of study, or also in the process of taking some additional lectures, it's portfolio. Basically, if you would like to have the online job or remote job, you need to have a very distinguished portfolio. What is portfolio? Portfolio is actually the collection of your work that shows what you are capable of. This is very simple, but in the details, you need to show like sketching skills or some sort of creative thinking skills, or the skills of CAD modeling, and so on. And most of the designers spend really a great amount of time just to make presentation and then with communication with the clients and so on. And maybe the real work is just 10% of this design. Other activities are like to communicate with the clients, to selling the ideas, and to make a presentation that the customer or client will understand what somebody has done, and if somebody has somehow addressed the design brief correctly. This is one pager of design portfolio. Here is just an example. So it's the name of a designer, contact information. We can see the design sketch on the left side. We can see the visuals like CAT model. This is something in between. This, I think this is the digital sketch. So we can see the examples that this person has made. If you are teaching your students CAT modeling, they can maybe use those CAT models for design portfolios. If you teach the students, for example, engineering design methodology, they can use it to present the flow, how they have developed the product. So this is also the portfolio. You can see the designer upstairs, and you can also see this is the page, coralfloat.com, when many designers are uploading their portfolios so that they can be visible to the potential companies for hiring them and so on. So we can see here is a brief explanation of what was developed, what was the background of the project and so on. And also the variety of designs that were created in this manner. We can also see design sketches. Design sketches are basically very cheap in comparison to 3D models or visualization process using CAD software. So they can be like created by hands, they can be created quick. So that's why they are somehow considered to be the cheapest way to communicate the initial ideas. Many design agencies are searching for very, very good design sketching skills. So if somebody would like to do in industrial design field, it will need to develop those skills. Another platform for designers is Behance. Behance is also the platform that offers for designers to present their portfolios, and on the other hand, they have also the job opportunities written then or labeled then in the web page. So they can check daily what are the opportunities to collaboration for, I don't know, production company, for design agency, marketing agency. Different sorts of collaboration is possible. So Behance is very famous. I think that also the Adobe package, Adobe company has some sort of collaboration with Behance. So somebody who is actually buying the software for illustrations like Adobe Photoshop or Illustrator or something like that, it has the instant access to the Behance platform, but also it's open to others. So you can just enroll in, create the account, upload the portfolio and try to find the opportunity to work online. So this is another example where we can see the design sketches and again, the background of the product, but also very good visualization skills like renderings, which looks like this is the real product, but this is not a picture. This is actually everything done in the virtual environment. So I will show you online opportunities where you can find the design job, or if you just would like to sell 3D models, or where you can find the additional courses, for example, for sketching, design sketching, or creating 3D modeling, and so on. So online opportunities, first, I would like to present you those remote work platforms. The first one is Fiverr, and you have a lot of opportunities to offer maybe just sketching skills, or to offer 3D modeling, or to offer the whole service of industrial design, or maybe also mechanical design. Then you have the people per hour. These are mainly just maybe for a little bit more smaller task to conduct. Then you have Upwork, Behance. This is really just for designers and creative profiles of people. TopTal is also for different kind of work remotely. Then you have remote.com and FlexJobs. I have spoken to my colleagues which are industrial designers, and also to colleagues which are graphical designers, and I have asked them, so how you get hired with using Fiverr or Upwork? And they just said that they started with using Fiverr at the beginning, but then later on, if they have done a good job, the companies actually establish a long-term collaboration with them. But at the beginning, they had really to do just one job for one company, and to really switch from one domain or one area to another, because they just needed some small tasks to be done. So it was not like immediate long-term collaboration. So they have said that with all these platforms, it needs some time. It has to be a little bit patient, but if you really impress the companies, then you can have like a regular customers with whom you again go on with the collaboration. Upwork, this is just an example how it looks like, the platform. So you create your own profile, and you create a statement like what you are doing, what you are offering. You also set the price per hour for your work. And it's very good to also have the hashtag, like what else do you provide? Like, okay, maybe you do 3D modeling, but you also knew, I don't know, how to work with Adobe Photoshop. So maybe it's good to list all the skills that you have, or all the softwares that you know, because sometimes, I don't know, one company will need at the beginning just 3D models, but later on the same company will need the graphic design. So if you're good at both, you can help them with different things. So I think that this can actually expand your how to say, potential to be hired or employed, for example, for the same company. Okay, and this is also the portfolio at the same page. This is from this person. So a few examples of his work, so that the customer or the client has opportunity to select based on the style, based on what the client has saw on the page, an explanation of the person. The another thing, so first, if you're selling like a service, like 3D modeling knowledge, or knowledge of illustrations, or I don't know, correcting the photos and so on, the previous slide is it is actually relevant. But if you would like to sell just components like 3D models or some animation or some specific thing that you are doing using CAD software, very popular site for this is CGT Trader. It is the website where you can upload your 3D models. You set the price and you can sell the 3D models. But I have to warn you here, it's more this page is dedicated more for gaming industry. So I recommend, based on what I have saw on this page, to also the students learn Blender, for example. Blender is open software. They don't charge you for usage or anything, and the Blender is in high demand in gaming industry. So, for example, if there are somebody searching for a building for the new game, and you are offering the model of the building, they can just buy it and they can somehow integrate it into the game, or I don't know, use it for any other purpose. Also for 3D models, it is TurboSquid. It is the platform from Shutterstock. Basically, if you know, Shutterstock is for selling pictures and illustrations. So the TurboSquid is for selling 3D models. So you can upload the models, and again, if somebody will need it, it can pay the amount of money that is demanded and upload your design. Another interesting platform is Shapeways. Shapeways is a Dutch company which is offering 3D printing on demand. But they have also the library of the 3D models. So you can be enrolled in this. You can upload 3D models there. And if somebody would like to, I don't know, have the pendant for the necklace or something like that you have created in 3D model, they will buy it, and the same company will do the 3D print of this CAD model. So again, here you need to consider the process of 3D printing while creating the CAD model. So these are some sort of limitations, but I think it's a good opportunity to have like some sort of, if you like to create CAD models, to actually upload it here. When I was mentioning, so basically, if you have like students that are mainly mechanical engineers and they would like to offer their skills to as industrial designers, they will probably need to adopt a little bit to the market and to maybe attend more classes online, for example, for design sketches, or I don't know, the classes how to create the portfolio, for example, in any of the graphical softwares and so on. So here are the online courses that I recommend. The Skillshare is one of them. Basically, they offer different lectures, different topics and so on. Udemy, it's also another platform. Domestika is especially for handmade products. So like for painting, drawing, and so on. Coursera, it's good because it offers also the certificates. So it offers the certificates. Sometimes Coursera also made a collaboration with the companies. So the company representatives are, I don't know, they demonstrate how they use some special knowledge or skills in their company and so on. So they really have the curriculum, if they collaborate with a company, for example, made tailored for some sort of company. But Also, they collaborate with other universities. They also have a bunch of courses which are very interesting, and you can earn the certificate. edX, very general. You can learn anything here, also in Future Learn. What I will apply here is that really all these courses are for, when I have presented, it's meant that you need some additional knowledge and so on. But sometimes also, if the students are very good, I don't know, in 3D modeling or any other things, they can also offer the knowledge as having the lectures in some of those platforms. So this is also the possibility. And what I see that maybe for industrial designers, it's very beneficial if they have the help from engineering designers or mechanical engineers. So if you have a very good students in mechanical engineering or engineering design, sometimes it's not needed that they have like skills of creating design sketches or so on. They can just offer like a mechanical engineering services and so on. So this could be very beneficial, for example, for industrial designers who are searching to have someone who will actually create the product for manufacturing process. Okay, so that was all from my side. Thank you for your attention. So if you have any questions, feel free to ask. I see here are some comments.
Okay, hi Vanya. Thank you for the presentation. So are there any questions from the public? The discussion is open, so please just go ahead and ask if you have any questions for Vanya. Vanya, you've gotten one applause from the public, so that's good. Okay, now is again is your opportunity if you want to ask any questions. Well, it seems there are no questions. So before we conclude the session, I'm just going to paste the link for the evaluation of today's sessions into chat again. And first of all, thank you, Vanya, for joining us, and thank you for your efforts and for your presentation, and thank you to all the people in the public as well for participating in today's workshop. So we'll continue tomorrow, 8 a.m. CET, with the workshops on CAD and CAM and machining. So we'll have a different group from our faculty presenting. Basically, yeah, let's continue tomorrow. So thanks again, Vanya, for everything, and thank you everybody for attending, and see you tomorrow.
Thank you. Have a good day. Bye-bye.
Bye.
Thank you.
Thank you. Have a good day.